Hello everyone, welcome back to my channel, and we are still considering our study on networking concept. We started this on day 8 and today is day 13. We are still considering our study on networking concept, and today we are going to talk about or look at a very important part of networking, a very important part of tech also, and that has to do with security. And we are going to streamline that to a particular tool or a particular concept called firewalls. So today we are going to be looking at firewalls. So one of the important things whenever you are working as a tech person, especially in DevOps, in system administration, in cloud computing, cloud engineering, is security. You need to secure your environment. You need to make sure that your environments or your applications, your servers are always secured at every point. And before now, we've looked at two particular methods in which we can actually use to secure our environment. The first one, which I touched on the first day, I touched on subnets, where you divide your whole network into subnets to prevent hackers or to prevent malicious activities from coming into your company or your system. That was where I did the illustration of where you separate a network for your finance team and then a network for the rest of your team. We're giving a VPC and all that. So if you missed that video, I think that's the very first day of our networking concept, which is day 8. So I advise that you go back and you watch that video before coming back here. Like I always say, every video that I put out or every day is layered on knowledge that we have had on the previous days before that particular day. So now, like I said, you create a subnet and you put your confidential information or your confidential IP addresses in a separate subnet from your public subnet, where anybody in your company can access network. So yes, but now the thing is that this only works when in this case now it is assumed that the hacker has already gotten access into the system. So let's assume that the hacker has already gotten access into the system. Then here's a particular part that you've protected, so where the hacker cannot get there. But there's a way to ensure that the hacker does not, or the intruder does not even get to the system in the first place, and that is where firewall comes in. So with firewall, you're even protecting any outsider, any hacker from coming into your system in the first place. Talk more of now trying to have access to some parts and all of that. So now let's define what firewall is. So a firewall in network security is a system that monitors and controls network traffic based on predefined security rules. It acts as a barrier between a trusted network and an untrusted network, preventing unauthorized access and malicious activities. Basically, this is just like a definition of everything I've just explained, where you don't even let the hacker or the malicious person or the external person gain access into the system. Talk more of even having access to other things, your different subnet and what have you. So like I have here, this is just an illustration. You're at the internet. So this red place, you've already set the rules for the firewall to block off some IP address or some traffic, and then you also set that rule to allow some traffic also. So now you might be wondering, how do we set that rule, or what does the rule come about? So firewall usually uses ACL tables. So ACL means access control list. So it's like a table that contains some informations where you the IPs that you are allowing, the IPs that you're blocking, destination, the ports, and all of the rest. So like what you have on the screen now, this is a typical example of what a firewall rule table will look like. So you can see under the permissions, you are seeing that some IP addresses are allowed while some are denied. So this particular picture now, IPs 192, any IP, any what do you call it now? Anybody can get access to these 4 IPs: 192.168.1.25 and 192.168.1.10. So any IP can access it either through IP protocol or the UDP protocol. While you can see the other ones that they are denied. So if you look at the port also, you can see that port 80, port 443, port 53 is allowed, while in some cases under TCP, port 53 is not allowed, and the IP protocol, port 53 is also not allowed. So firewall rules can be based on so many things. It's not just only IP addresses. Firewall rules can be based on domain names. It can be based on protocols. It can be based on programs, on ports, even keywords. So some firewall rules can be configured to on a port basis. So like we covered everything about ports yesterday. If you've not seen that video, so you can also go back to that. That's the 12th. That was yesterday. The 12th. That was yesterday. So you can go back, understand what ports actually is, different types of ports, different category, and everything about ports. So some firewall rules can be based on ports, where you can say, okay, we are allowing traffic to come from any traffic going to port 80, any traffic going to port maybe 443, that's your web interface, that's your HTTP and all of that. Any traffic going to maybe port 22, which is your SSH, you can allow it, while you can deny traffic going to some certain port, like your port 53 now, like which is DNS. So you can do that. So basically these are usually set by the system administrator. So they can set the firewall rules and everything. We are going to be doing, of course, we're going to be doing a practical on this session. But before we go into that, before we go into the terminal and start getting our hands dirty, I always prefer to explain things so that you understand very well what we're about to get into, so that by the time we start doing one or two things, it doesn't look strange to you, because now you already understand everything about it and what it is all about. So basically, yeah, this is how the firewall rules, is how the table looks like. You can allow access, you can deny access depending on an IP address, depending on a port, depending on domain name, depending on protocols and all of that. So this is how it is done. So now there are two major types of firewall, which is the host-based firewall and the network-based firewall. So the host-based firewalls are like just firewall applications that are installed on your system or your computer. These are host-based firewall. They only protect that particular system. They only protect that particular computer. For example, your typical example is the antivirus and all of those other applications like that. So these are host-based firewalls. They only protect your system. So if a malicious traffic comes into if it comes through the router, it will go through the router. But when it gets to your system, if there's a rule against that particular traffic, it's not going to go through. So host-based firewalls basically just protects your system. It is configured at the system level. That's your host, your laptop, your VM, and all of that. While there's a second type of firewall, which is the network-based firewall. So this particular firewall protects the network, the entire network. It protects it. So let's say, for example, now you have like you have a VPC, and you have like 65,000 IP addresses and all of that. So if you create a network-based firewall, it protects the entire network. So this is at the network level. So no malicious activities even comes through the network in the first place. Talk more of going to your host. So network-based firewall protects the network. No one is going to come through. If you set the rule at that network level, nobody is going to be able to bypass that rule if the rule doesn't permit that person from going through that network. So before it even hits your host. So you can this network-based firewalls, you can have them as a standalone device. usually, you can have some network-based firewall as a standalone device, like a normal device, and sometimes they are usually configured at the router level. You can configure it in your router. You can put like a network-based firewall in your router. So basically, this is just to protect your network. But in most cases, for you can never, you can actually never be too secure. You can actually never be too secure. So most organizations prefer to use both the network-based firewall and the host-based firewall. So it's better to be double sure than to just leave everything to chance. So if by any means on unauthorized traffic goes through the network, at least you will still be a little bit rest assured that your host-based firewalls are still up. So basically, most organizations use both the network-based firewall and the host-based firewall for maximum security reasons. So now let's that's basically everything about theoretical firewalls and everything. So I believe that I've been able to explain what firewalls is. I've been able to explain how firewall works, the rules, how the rule table looks like, and basically the different rules that a firewall can be based on. So now let's we are getting towards the practical aspect. So since our main focus on this particular part of this journey is we're working majorly with Linux system. So I would like to tailor everything we are doing down to Linux. So now we have under firewalls for Linux. Basically, we have 4 types of firewalls. So we have the IP tables, we have the RUF table, we have the NF table, sorry, we have the UFW table, UFW, and we have the firewall D. So we are going to be focusing on IP tables and UFW. So the IP table is just like, it's all these tools, they're actually command line tools. So we're not going to do firewall D because we are working with an Ubuntu system. So on the first day we installed Ubuntu system. But if you are working with Red Hat, or if you are working with CentOS, we are going to be using firewall D. That's the firewall command for CentOS and Red Hat, while UFW is the command for Ubuntu and the likes. IP tables is, you can use IP tables generally. So this is basically the types of tools that we work with, the type of firewall tools that we work with in Linux. So we are going to be going to the terminal soon. So but before we go to the terminal, now let's take IP tables. Let's consider IP tables. Basically, this is a classic Linux packet filter. So it just shows you your firewall table, your rules and everything, what you allow, what you deny, and all of that. So if I come to the command is actually IP table. So if I come to my terminal and I do sudo IP tables -l -n -v. So basically, this is just the -l -n-v is just to list the tables in a more detailed way. -l means list the table. -v means verbose. Verbose means like in much more details. So because I'm using sudo, it's definitely going to ask for password. So this is what you see when you type IP table. So it shows you all the input. You will see chain, you see input, you see dropped 31 packets and all of that. So you can use this to check. These are the forwarded traffics. These are traffics that are coming into your system. You can see there it's written input for forward. These are traffics that are passing through your system. So you can see there are no packets, there are no bytes. So, but here we have 31 packets. So, and I'm responsible for all of this because I know I did some I configured my UFW before we had this, before starting this session. So right for output, there are currently no packets going out. That's packets leaving your system. So basically you can just go down and check. You see more details about all of your activities. You can see it's just basically a very, very detailed explanation of everything that is going on with your firewall. So it's very, very detailed. You can just take your time, go through it. When you type this command on your terminal, you just take these are like explanations of the summary of the things that have been shown up. So it's just to give you more details, because I used the flag -v. -v gives you a verbose output, which is a very, very much detailed output of all of this. I can't start explaining everything one after the other, but on your own end, you can take your time to look into it one after the other, because if I do, we are going to take so much time. So this particular one, this UFW user input, so you can see port 22. So what happened was that before now, my firewall, which is UFW, it wasn't enabled, it was disabled. So about a couple of minutes ago, I had to enable it because of this session. Like I said yesterday, this particular VM, nothing is running on this VM. It's just used for the purpose of learning. So I didn't enable the UFW command. So I just had to enable it a couple of minutes ago. So that's why you can see this here, it accepts, and you can see port 22 here. So that's just a little explanation from there. So now, when you want to, on iptables, you would understand that, or you will notice that we saw stuff like input, output, forward, and the likes. So that brings me to the next thing, which is under iptables, you need to understand what we call tables, chains, and rules. So basically, what is a table? A table is just like a category of purpose for handling a traffic. Let's say there are different tables. The first table we have is the filter table. The filter table usually the purpose of this particular table is to accept or to drop traffic. So basically, it's to accept or to drop out traffic. That's why you see things like input, output, forward. So when we just check the terminal now, we sort things like input, output, forward. So we also have NAT. If you don't know what NAT is network address translation. So I also covered that in one of the previous videos. You can also go back to check all of that. So basically, it just translates addresses. So it's just saying, should I translate an address, or should I allow this or should I forward this particular address or this particular IP to another place? So that's why we have the pre-routing, the post-routing. Basically, this is done, for example, if you know what is called load balancing. So we'll also get to a point where we talk about load balancing. So a load balancer usually it receives traffic. Most of the websites that we actually access, websites like Amazon, or the top websites, most times we don't access the servers directly. Most times we always go through a load balancer. You might not know, but that is usually how the architecture is. No organization, no top organization gives you direct access to their server. So most times it always goes through a load balancer. So when I get to the aspect of load balancing and load balancers, we'll be able to talk more about that. And so if you don't understand what load balancing and load balancer means, you can either Google search on your own, or just hold that thought till we get to the area of load balancing. So, and this Mango is like an advanced use. We're not going to talk about that. So majorly we'll talk about the filter and the NAT. So if that's an definition of what a table means. So let's talk about a chain. The chain is, in every table there is something called a chain. So a chain is a series of rules inside a table. A chain is a series of rules inside a table. So each chain handles traffic at a specific point in its journey. So now we are breaking all of this. These are chains. So we're now breaking all of this down to see what they handle. So the input chain, it handles incoming traffic into your machine. For example, the SSH, your HTTP, and all of that. The output chain handles outbound traffic from your machine. Your call command, your wget, which is used to send or reach out to a particular website. I think when we're doing I think on the same day we considered IP address. I think it was that day or the following day. I know we used the call command, which we used it to access a particular website. So the next is the forward chain. Like I said, a traffic that passes through your machine. So your NAT, your Docker bridge. When we get to Docker, we'll talk about all of this. So now the next is the pre-routing, which is like I said, load balancing and all that, and then post-routing, your NAT and masquerading. So let's go to the terminal and touch on some things. So we are going to do some practicals now. But before that, by default, your firewall rule is it denies all inbound traffic and allows all outbound traffic. So by default, this is what your firewall rule looks like. It denies all inbound traffic and allows all outbound traffic. I will give you a quick example. A couple of minutes ago, I said I had to enable UFW on my virtual machine. So now we all know that this is not actually the CLI interface of my virtual machine. I access this through SSH client. So when I enabled it through this particular SSH client, which is Mobile Extend. When I enabled it, I noticed that I couldn't, SSH into my virtual machine from this client. And I didn't notice it until when I was about to do something. Then I discovered that I couldn't SSH. Immediately I saw that, I quickly remembered that I already activated the UFW. So immediately you activate that UFW, this default rule comes into play. And if you're following, you would see that SSH is a part of incoming traffic. And I also said the default rule is to deny all incoming traffic and allow all outgoing traffic. So what happened was that it ended the session. It denied the traffic coming from my SSH client to my VM. So what did I do? I had to go to my VM's interface and I had to allow, if you can see there, I did sudo UFW allow port 22, which is the SSH port. So I now allowed it, and then that was when I was able to SSH back into my VM through this particular SSH client. So like I said, by default, your firewall rule is it denies all incoming traffic and it allows all outgoing traffic. So now let's now say we want to use the IP. Now we are still considering IP tables. We've not gone to UFW. So let's say we want to allow SSH, which is on port 22. Okay, we already did SSH for UFW. So let's say port 80. Let's do port 80 for HTTP. So what's the command for that? We do sudo iptables. So -a input. So now input means that we are setting a rule for an incoming traffic. So this is -p. So you have to specify what protocol are you using. Are you using the TCP or you are using the UDP? So TCP, then you have to specify the port. Which port are you allowing? So we are allowing port 80, and then we're going to accept it. We're going to accept the packet. So sudo iptables -a, which chain, which is the input chain, and then -p, which protocol are we using? We're using TCP, because on our video or on OSI model, we specified that there are some packets that should be transferred through TCP, while some should be transferred through UDP. Example of TCP is stuff like your SSH should be done through TCP, while UDP you can use DNS. You can use UDP for DNS, for stuff like DNS. So it's just like that. So you specify, then you add the port and you accept. So click on enter. So that has already been done. So let's check sudo iptables -l lists, and let me see. I don't want to use the variables. Let's see. Iptables. Okay. So let's say if we are going to see what we just allowed. So you can see it here. Accept. Just accepted it. So TCP port 80, and you can see that it's accept, and you can see that it is under the input chain. So you can see that it's under the input chain. So that's how you can check your iptable rules, and you can play with it, include some rules and everything. So let's say if we want to deny, let's see. So let me just so I'm trying to now deny this now. So iptables, input traffic port 80. So let's drop it. Let's drop it and let's check. Let's check if there's going to be changes. So let's go up, and so you can see it also that we've dropped it. So you can always monitor all of your activities, and you can see it is still under the input chain. So since everything we are doing is under the input, like I stated it here. So if you're doing everything under the input chain, whatever rule you modify, you can always come to your iptables, check. If that rule is there, you will see it if it is accept or deny. If it is accept or drop. So accept means you are allowing traffic, drop means you are disallowing traffic. So then you can see the port. It will show the port here, and it shows that from this is the from anywhere. This is the source IP address. It means that you are denying traffic from anywhere to anywhere. Like I said yesterday, once you see 0.0.0.0, it means like from anywhere. So or you see star 0.0.0.0 or star means like you're trying to whatever you are modifying has to do with like you're modifying it from anywhere. So that's basically how you accept and drop traffic using iptables. So the next we are going to consider is the UFW. So I told you we are going to be working with iptables and UFW. So this particular command is only specific to Ubuntu. So this is just basically like it's a very, very simple command, no stress, just straightforward, straight to the point, and the command is UFW. So you can check, first of all, you check the status, systemctl status UFW system status. So you can see before you start using it, you can see that you ensure that it's active. You can see that it's active. You can see that it's enabled. So the difference between, I don't know if I've mentioned this, but the difference between active and enable means that when you activate, sometimes you can see a service will be active and you can see it that it's going to be disabled. What does this mean? Active means that it is currently working. It's currently, the action is currently, this particular service is currently running. That's what it means by active. But when you see enable, it means that whenever you shut down your VM and turn it up again, the service will start up automatically. So if you come here and you see you can see, if you come here and you see disabled, let me even show you. So you can see, I can say disable. This might actually cause an issue with this terminal, but before I disable it, I'll disable it when I'm actually done. I don't want a case where my terminal would exit, but let me try it. Let's disable it. Disable UFW. So sudo systemctl disable UFW. So it's disabling it. So when I do status, you can see that it is active, but it is disabled. So now, the moment I shut down this my VM, when I turn it on again, this firewall service will not start. So I will have to go and manually start it by doing sudo systemctl start firewall. Then I will enable it. So disabled means that it's active, it's currently running because I'm using it right now. But once I shut down my system, this service will go down. This service will go down. Once I restart it, it's not even going to come up again. So if you want a service to always, start once you turn on your VM, or once you start your VM, it's better for you to enable it. So I'm going to leave it as disabled. If I shut down the system, it's going to disable, and we'll see where that goes. So UFW is actually a very simple and straightforward command. If you want to allow traffic, you can say let's do UFW. Let's do sudo UFW. Let's allow traffic from port 443, which is HTTP. So you can see that's just the simple way of adding a rule using UFW. It's a very, very easy command. It's either you allow or you deny. So if I do UFW status bubbles, I can see status active, everything. You can see that it's disabled, but it is active. So you can see the rule. Port 22 allow in from anywhere. You can see port 443 allow in from anywhere. So I can change this to I think is it deny? Okay, so let's check. So you can see it here. Port 22 allow in from anywhere, but port 443 is deny in from anywhere. So anybody trying to access this particular anybody that's trying to communicate or that's trying to come into my VM using port 443, it's not going to allow you. Let's say I have a website, HTTPS website that is running on port 443. Nobody will be able to access that website. So sometimes you might see that your website is up, but nobody can actually access it. Some of the places that you can check is your firewall rule. So check your firewall rule. If port 443, port 80, or the normal ports, that's the first thing you check, if it is actually allowing traffic inside your VM or inside your server. So basically we've already touched on firewalls. With this, you can be able to troubleshoot any issues with firewall. You can use iptables, you can use UFW if you're using Ubuntu, you can use firewall D if you're using Red Hat or CentOS. So basically we've covered everything about firewalls. Or if there's any other thing that I skipped or that I missed out, or there's something that you don't understand and you need more explanation on, you can always drop it in the comment section. I will be very, very happy to buttress and explain myself better. So that'll be all from me for today. I really hope that you've been able to learn one or two things about firewall, and not just learn it, you've been able to practice or do hands-on regarding firewall. So you can play around. You have your VM, you play around with the firewall, you set rules, you set different rules and all of that, and then you test if everything that you're doing is working. So I'm going to see you again tomorrow. Till then, cheers.